correct, right? So based on that previous mock-up, I think maybe because you have to keep thinking about it. Why? Because I'm kind of give you this just one example. We are the old human, all has a different thinking procedures, or even though same people can build a same model, right? You maybe can draw beam or column or walls in different sequence, which means sometimes mm, you may have to uh, play around or understand all more deeply. Because I mean, a plus b. Eventually, we know that 1 plus 1 is 2. A plus b is somehow c. But if you drew b first, right, instead of a, there is something sequential impact. So generally, it's kind of drawing is drawing, but structural intentions we should really get more. We need to get familiar with. So, sometimes you may have to draw a beam first, or a slab first, or gutter first, right? Maybe people can draw in different way, but down the road, at the end of the day, output should be same or identical or very similar. So so that's why I like to address more openly. But bottom line here, we're starting with the grid, right? That's give us the more easy control. But I probably have to explain one thing that most of building is not rectangular shapes, or some column or beams and wall. It's not on the grid line, or all the skewed. Then how are we gonna start with the geometry? Um, Very likely we are using AutoCAD, like an architectural background, right? So DXF or DWG, we bring into ETABS as a architectural background and use all the reference line and define that center point of the column and walls, because usually architect, they don't draw the center line on their architectural drawing um, until they establish the grid system. So maybe you can visualize a concrete column. They draw the square, right? They don't draw the center line of a column. As a structural engineer, we have to pick and and those points for the structural analysis purpose. So we have to draw our column on the center line base. So that's some additional tip. Probably I'll show that maybe in next class, especially concrete structure, concrete building. That is very common case, but still, I think is relatively more regular, and you could start with a grid system like this. Now, so just as you know, maybe you can think about it. I mentioned a coarse mesh is okay. It's because you don't have to draw many slab. This is just controlling, managing how more efficiently you have to uh, manage and build that your model. So the coarse mesh for especially Metadex slab is very, I think it's a good strategies. So let's say you think it's good idea, and all the Metadex slabs running perpendicular to pillar beams, right? Low beams. But one thing that this is metal deck, I think go back to metal deck section property here. I opened the metal deck property. You see this? Oh, let me uncheck. Do you see that screen? Metal deck later.
Yeah, we, yeah, Here we can see it. Mm-hmm.
Okay. So, and the few things, I think so far most of your geometry is set except few, the inside the core. But section property and material properties is dependent designer's intention. Those intention is based on our industry, engineering industry practice and design criteria. So structural design criteria I point out, highlight a couple of times. So you should, based on that criteria, you should build and define that materials properties and section properties. Here, I just click it and see that what metal deck property was assigned. I think this default, it types deck one. You don't have to, you, you should maybe come up with some, or company has their own system sometimes, or it's engineering judgment. If this is metal deck slab, I will just metal deck slab. Maybe I will just type it 3.3.5. So 3-inch metal deck plus 3.25 inch. This is lightweight concrete. So you just come up with some name for your kind of um, for managing purpose. So here, lead deck is metal deck slab, right? And slab depths is 3.25. So you maybe can see that if this properties belongs to field deck has all nomenclature. So TC is slab concrete topping. H sub HR as a metal deck, and also metal deck valley has a spacing and width. I think you maybe can adjust it as needed, but generally, rib metal deck and concrete thickness are most important for that configuration. And here, slab material somehow is Fusion 6000, but this is metal deck concrete, especially we don't need a high strength concrete. Our industry commonly use 3500 versus 4000 psi concrete. More and more, we prefer to use more 4000 psi concrete, right? But we need to make sure this should be lightweight concrete. So I think default is normal weight concrete. Let me just go back to the define material section. So I think currently we have a 4000 as a default. Let me check. See that weight per unit volume default 4000 psi is assigned as normal or 150 normal weight concrete. So I'm gonna copy this. If you want, keep it 4000 psi, but I'm gonna say lightweight concrete LWT, but weight per unit volume is 115. Not 150 pound per cubic foot. So I create a lava concrete material here, right? And go back to section metal deck sections. I'm gonna change to lightweight concrete because it calculates flow weight differently, right? So especially material and section properties, they are associated each other. So we have to keep to build these properties based on your design criteria and use. Because this is something relatively common and routine task. Uh, you don't because default ETABS doesn't provide preset material properties. This is kind of annoying, maybe tedious. So once you maybe have one good model, complete model, maybe you can use it as a template. So ongoing, you don't have to keep doing the routine tasks, for among the each project. But anyway, here I show you